An ion is an element that has either gained or lost electrons. Okay? So, ions. There are positive ions, and a positive ion is going to be called a cation. And I remember it because positive is, a plus sign, and cation has a T in it that, especially the way I just wrote it there, looks like a plus sign. Then there are negative ions. And negative ions are called anions. Okay? So, sorry about the smacking. I sound like the Joker. Anyway, if I have an element, now I'll go back to phosphorus. I used phosphorus in last time I did this. It had an atomic number of 15, and let's round off the mass number to be 31. Now, since the atomic number is 15, that means I have 15 protons, positively charged particles making up that nucleus. Okay? Since the atomic mass was 31, if I subtract 31 by 15, I am going to get 16, which is the number of neutrons. So in this particular phosphorus, there are 16 neutral charged particles. And remember, those are the things that are holding the protons together in the nucleus. Now, as this is written, this phosphorus symbol would have an equal number of electrons, would have 15 electrons, because it is written as if it were a neutral element. There is no symbol right in here. Okay, the absence of any symbol, charge, positive, negative, whatever, means that that element is going to be of neutral charge. So that's that phosphorus. Now, what would happen if I wrote another phosphorus down here and it looked like this? Phosphorus 15, 31, okay, but this time I have a negative 3. What that means is, still, this phosphorus has 15 protons, because protons are what make an element that particular element, and 15 protons means that it's phosphorus. So nothing changes. It's still phosphorus. Same symbol, same protons. The neutrons turn out to be the same as well, because I haven't done anything to that. So I have 16 neutrons in there. Now what I just did is I have this negative 3 charge right here. Well, you can't, an element will not change its protons, because then it would become another element, and that's called transmutation, and it doesn't happen unless you do some really fancy stuff to things. So where this negative 3 comes from is the net charge of the atom has changed by 3 negative charges, which means it gets 3 extra electrons. So whereas I had 15 electrons when it was neutral, I now have to add 3 more electrons to it. And by adding 3 more electrons to it, that's going to give me a total of 18 electrons. And that is an element, or an ion of phosphorus. This phosphorus has gained 3 electrons. The electrons are the only movable subatomic particle that can be gained or lost. So that's how you figure that out. Now, I could go the other way. I could be talking something like calcium, okay? And calcium has an atomic number of 20 and a mass number of about 40, meaning I have 20 protons, 20 neutrons, because 20 plus 20 equals this 40. And because there is no reference to a charge, there's nothing right here that's blank, I am going to have 20 electrons. So 20, 20, 20. All right. But what if you happen to look at this calcium and you notice that there happened to be a +2 charge on it? Well, that +2 charge now means that I have 2 more protons, 2 more positively charged particles than I have negatively charged particles. Got to remember that the electrons can come and go. That's kind of what chemistry is about. I could change the name of this course to, instead of chemistry, the study of electrons. But so the net charge is a +2, meaning that I am going to have sitting in there, oh well, it's actually around it, 18 electrons. You got to get used to that. In a way, when you see a positive charge here, it means you take away from electrons. Okay, so that positive right there means you took away from the atomic number 2 electrons to get 18. I'm not really sure I wanted to, do that. Again, I messed it all up. Looking over at the phosphorus example, the opposite happened. I had 3 extra electrons. Since it's a minus there, I end up adding that number to the protons to get 18. That's it.